So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, solar system upgrades are becoming increasingly necessary. That's because people who already have solar, they're going to need more power as they electrify their home. They might put in a heat pump HVAC system, they get an EV or a second EV, installing a heat pump water heater, using an induction cooktop, getting rid of their old gas stove, and then we even have some customers who are getting a second EV. And also, at the same time, because the grid's becoming less reliable and it's beneficial to time shift your energy use, people may want to add a battery to their solar system. So not only do they need more panels, but they may need a battery. So as Tim Allen would say on home improvement, I need more power. But unless you want to pay your utility more money forever, that means you need more solar panels and a battery, both for backup and to time shift your electricity usage. But it's not always easy, since your original system was designed to optimize the spacing on your roof and the collection of energy on your roof and the efficiency. And the reality is, upgrading an existing system is much more difficult than the initial installation. You have to make sure that the new solar panels, the new inverters, the batteries are compatible with the old system and going to meet your future needs. You also have to make sure that your electric service is big enough for home electrification or for adding more solar panels. It's very tricky calculations. So you need to find a company that has many years of experience with older solar equipment. Otherwise, they're not going to have a clue what they're messing with. And we've had experiences where some other contractor goes in, they're kind of new, they might not have been familiar with the way things were done 10 or 15 years ago, and they could easily make some mistakes. So it's really good for you to kind of go through the details of the upgrade process of your solar system. So there's two basic kind of upgrades that we're going to talk about on today's show. First, the more straightforward one is adding more solar panels. The second is adding a battery. We're going to start with adding panels because it's a little bit trickier than just adding a battery. It's a lot easier just to say, I want to add a battery to an existing system, and pretty much batteries are compatible with everything. All right, so first, if you're going to add more solar panels, obviously you want to try and determine how many more solar panels you're going to need. Your electrification contractor can help you with determining how many more panels you need for electrification. It's not an easy kind of a standardized calculation. For example, depending on how much heating you're using in your house, you may need 5 more solar panels to generate enough kilowatt hours for a heat pump HVAC system in a very warm climate. Or if you're in a really cold climate where you're going to be running the heat a lot more, you may need 10 or 15 more panels to generate enough kilowatt hours to keep your house warm in the winter. Second, you may want to get more panels for your EV. So regarding EVs, its calculation is a little bit easier because you can see how many miles you drive per year. You can see how many kilowatt hours per mile are required for you to drive your EV, and then you can do that calculation. So typically you're going to need between 5 and 7 more solar panels, and those are the bigger 400-watt panels, to power your EV for about a year. So that's how many panels you need to meet your electrification needs. But now, let's see what fits on your roof. So most solar contractors use software to figure out how many more panels will fit and account for the efficiency of those new panels, because panels on the north roof obviously aren't going to be producing as much energy as panels on the southwest roof. And third part of the calculation, third way of figuring out is, what's your budget? You want to consider not only the upfront cost, but how much additional savings you're going to generate every year from this expanded system, and kind of look at the financing options if you're not going to be paying cash. Obviously, you want to work this out with your spouse and make sure that you're spending your money in the right way. Okay, so now that we're kind of getting an idea how many panels you need, it's tricky to find the space for these new panels because your original solar installation should have been done to put the solar panels on the roof segments that are going to generate the most energy. That's generally an unshaded part of your roof that's facing south or southwest. So when adding new panels, because that south or southwest roof already may be fairly full of panels, you're going to want to start considering other roof orientations. And what's interesting that's happened over the past 10 years or so, we used to be ignoring the northern-facing roofs, the northwest, north, or northeast, because sun, at least in the northern hemisphere, is mostly towards the south. But because the cost of the panels has come down so much and the efficiency is better, we find it almost always makes sense, as long as your roof isn't really, really steeply pitched, it almost always makes sense to add more panels on some of those suboptimal north, northeast, or northwest roofs. A good installer will use software and take the shading, the tilt angle, the orientation of these roof areas into account to figure out what the actual kilowatt hour generation is on those suboptimal roof spaces. And when I'm saying suboptimal, we're not talking about a big difference, maybe 20 or 30% difference in output on the north roof versus the south roof. And if your roof is flatter, the lower the slope, the less there is a difference between those two roof areas. Okay, so we talked about how many panels, where you're going to put the panels. Now let's talk about older systems. And in our experience, and it sounds a little crazy, but we're generally finding that systems that are over about 15 years old, it almost always makes sense just to replace all the panels and replace the inverters or electronics. Now, it sounds crazy, but when you kind of go through the numbers and you look at the efficiency and the extra cost to get this old stuff to work and how long the old stuff is going to continue to work, it usually makes more sense. So here's the most important factor is new solar panels are over 22% efficient. You can get the highest efficiency panels, really, really great. Whereas the older panels, like 15 years ago, 20 years ago, they're only 14% efficient, and their output has declined over the years. The other thing is these older panels generally don't have optimization or microinverters, so when you have shading or degradation on one panel in a string, you get a big energy loss. So all in all, when we're looking at the power output from an old 15-year-old system compared to a new system, you can often get double the energy output with new panels, both because of the efficiency is higher and also because of the degradation of the older systems. Plus, newer inverters are almost 99% efficient. That means that you're only losing 1% of the energy on those newer systems. And the older inverters, 94 or 95% efficiency, and obviously their efficiency has declined. The other thing about older systems, and this is kind of where you start running into a jam, is warranties on inverters are typically between 10 and 12 years. Microinverters might be 25, but then there's other issues with microinverters. We'll talk about that in a sec. So if you have these older systems, sometimes it doesn't make sense to repair them. We've tried to use refurbished inverters. You get an older inverter, it's a common inverter, let's say an SMA inverter. There's lots of refurbished SMA inverters available on the market. But if somebody refurbishes them, they generally don't provide a warranty for more than a year. And in almost every single case that we've tried a refurbished inverter, they die again within less than a year and you're back to where you were before. So here's the other consideration. If you have an older system, 15 years, 20 years ago, and you want to add new panels, you may want to consider re-roofing those roof segments at that time because you want to have that new system up there for another 15 or 20 years, and at that point, the roof area underneath that section is going to be 30 years old. The roof is probably going to need to get redone. So consider re-roofing at the same time you make a major addition or replace your old panels. And keep in mind, the roofing work related to solar qualifies for the 30% tax credit. So if you're spending $20,000 to re-roof your system, you're going to get a $6,000 tax credit back. It's pretty valuable. All right, some other technical limitations that I just want to let you know about. There's often limits on the size of the inverter based on the size of your electric panel. For example, if you have a 100 amp electric panel, that can handle a maximum of a 3.8 kilowatt inverter. And these are calculations and designs that your original installer and your local inspector has verified. If you have a 125 amp electric panel, it can handle up to a 7.6 kilowatt inverter capacity if you downsize the main breaker to 100 amps. And that's something that's very common in my neighborhood because all the houses have 125 amp panels. People want to put in 7.6 kilowatt inverters. They just downsize that main breaker to 100 amps, then everything's completely compliant with codes. If you have a 200 amp panel, the maximum inverter is 7.6 kilowatts. But then again, if you downsize that main breaker to 150 amps, you can go up to a 11.4 kilowatt inverter capacity. And generally, that's pretty much all you need for full electrification. So make sure you discuss the available electric panel capacity with your installer when you're considering adding more panels or adding a new inverter. Now, let's talk about the types of inverters you're going to put in for these new panels, because the technology has changed a lot over the last 15, 20 years. Most older systems use inverters from companies like SMA, ABB, Keiko, Fronius, etc. These inverter companies are generally not that active anymore in the United States because they didn't really make a good transition to the new technologies of optimizers and microinverters. So you're almost always going to need a new inverter to add a meaningful number of new panels. That old Fronius inverter or SMA inverter is really not going to be compatible. So when we kind of look at the options to do that, if you have an older SolarEdge inverter, they've been around for 15 years, pretty easy to upgrade that to a bigger inverter, and it's not going to really affect what's going on with your optimizers because SolarEdge did a good job of being backwards compatible. So, for example, in terms of upgrading these inverter sizes, if you have a 5 kilowatt inverter and you want to add 3 kilowatts more panels, what's going to happen is when you're generating, say, maybe almost 8 kilowatts on a sunny spring or fall day, you're going to get a lot of clipping. You're never going to get more than 5 kilowatts. And that's called oversizing the solar panel array to the size of the inverter. The DC to AC ratio is, might be 1.5 to 1. And that may void the warranty on the inverter. And you're also going to see a lot of clipping. So in that case, if you want to add 3 more kilowatts to your 5 kilowatt system, you're really going to need a 7.6 kilowatt inverter. Now, these calculations get a little bit different when you're talking about microinverters. They're generally, you can add more microinverters onto an existing system, but there's a little bit of a hitch. We'll get to that in a second. Okay, so the other thing, if you have one of these older systems, and you have to really compensate for this, you really can't add a new 400 watt panels. Let's say you want to add 5 more panels, 400 watt panels, 2000 watts. You really can't put those new panels in the same string as the older 300 watt or 250 watt or heck, even 175 watt panels you had. So the reason is that strings of solar panels are all wired together in a string. They need to be very carefully balanced to make sure that you're not exceeding the voltage or the power on that particular string. So in that case, microinverters and optimizers are often the best solution in these cases. So if you have a system that had microinverters or optimizers, it's a little bit more straightforward to add more panels because you can put in more microinverters and more optimizers. So talking about that, Enphase microinverters and other companies and microinverters they're really great for adding more panels because everything's done on the AC side. You're just adding 400 watts more. Or let's say you have a 350 watt microinverter with a 400 watt panel, it's usually okay. You can just add 1 or 2 or 3. Now it's kind of complicated to do that because the contractor has to go out and put those in, but from performance standpoint and a safety standpoint, it's pretty easy to do that. You're not going to be violating any electrical rules. But the dilemma is the older microinverters are not compatible with the new microinverters. It's something we call backwards compatibility in the industry. So the new panels on the new microinverters will require separate wiring from the roof down to the older systems. Not that big a deal. It's manageable. And the other thing is because the monitoring is different for the older microinverter systems than the new ones, you're going to need kind of a separate set of monitoring. So basically what we do is if we want to add 10 more Enphase panels onto an existing Enphase system, there's just a separate monitoring system for the old Enphase and the new Enphase because they're not really backwards compatible. We've tried to kind of do this, but it's just endless hassles of trying to upgrade firmware on dozens of old microinverters, and it's just not worth it. And it's also generally pretty expensive to replace the old microinverters with new microinverters. At that point, once again, the system's probably 15 years old. It may not be really worth going through that hassle. Now, with SolarEdge, it's a little bit easier. They have a good track record for expansion because even the old SolarEdge optimizers are backwards compatible in all respects to the new system. So we can put in a brand new inverter, brand new optimizers, and connect those to the older systems. It works. So SolarEdge system, relatively easy to add more panels. You still have to be careful about making sure you have the right number of panels on the string, but at least there's complete backwards compatibility. Now, a lot of people may have some older SunPower systems, and I was one of the original SunPower dealers. We installed lots and lots of SunPower systems, and from 2004 on to about 2010. The thing is, SunPower panels that were made before 2016 require a positive ground inverter. It's kind of, now we're getting technical, but all of the older solar SunPower systems use positive ground inverters. But those positive ground inverters are no longer being manufactured. And all the inverters you can get from companies like SMA and some others, they're all negative ground. And it's a weird thing about electricity, but if you put solar panels that are designed for positive grounding on a negative grounding inverter, you're going to avoid the warranty on both the inverter and the solar panels, and you're going to lose a lot of production capacity. So that's something to keep in mind. So when, not if, when your old SunPower inverter dies, and this is for systems older than about 2016, your solar panels are basically obsolete because there's no inverter that we can get that's going to work with those old SunPower panels. This is not the case with newer SunPower panels. 2015, 2016, that's when the transition happened from positive ground to negative ground SunPower panels. So you're okay. But if it's an older system, you're kind of in a jam. We will generally only remove all those old SunPower panels and put in a new system, state-of-the-art, new inverters, microinverters, optimizers with high-efficiency panels. So we talked about the inverters. The monitoring is also very important these days. But here's the thing. Rule of thumb. Inverter companies have their own proprietary monitoring system. So every inverter company has software that works with their inverters. And if you have two different inverters from two different manufacturers, or even sometimes an old inverter from one company and a new inverter from that company, you're going to need two different monitoring platforms. Enphase is a typical example. I've got an old 2009 Enphase system on my house with this Envoy that's circa 2009, and it doesn't work with the new monitoring system. So my only option is either to replace all those microinverters or have two completely separate monitoring platforms. Not that big a case, and there's a good kind of way around this if you just put in an AC coupled battery. We'll talk about that more later. Okay. As far as adding new systems, there's a new code requirement, really not that new. It's been around for about 8 or 9 years. It's called rapid shutdown. So in order to get a signed off building permit, you're going to need to show that the addition of your new panels is code compliant with these rapid shutdown rules. And rapid shutdown basically means that all accessible high voltages on the roof must be turned off by turning a simple switch off or turning off the inverter. And this is really an important factor if there's any kind of fire issues or first responders want to turn off the system. All new systems are compliant. Old systems are not. They're almost always safe. And they're also grandfathered by your inspector. So if your inspector comes out to see the new system, they generally don't really look at how the old system is operated as long as they're not electrically combined. All right. We talked about a lot of these limits. Now there's kind of a bizarre limit that's arbitrary. It's imposed by your utility. Utilities limit how much you can expand your system. Why? Because they don't want to lose more revenue. And they made a rule that says basically if you expand your system more than X, you no longer qualify for net metering or you have to go on new net metering. This is a huge issue in California. The rule from California utilities is if you expand your system by more than 1,000 watts, that's like 400 watt panels, you lose your net metering grandfathering. That doesn't mean that you can't put it in. It just means that if you expand your system in any way by that's more than 1,000 watts, you're forced to go onto net metering 3. And net metering 3 is a terrible electric rate, terrible state policy. You no longer get compensated at the retail rate for excess power you're producing. You only get about a nickel a kilowatt hour when you're running the meter backwards. Right now, if you were on net metering 1 or net metering 2, you get almost the full retail rate, about 25 cents a kilowatt hour during the day, compared to a nickel a kilowatt hour during the day. So in California, you have to be very careful about adding new solar panels. You can install a storage battery without using these net metering benefits. And depending on the design of your system, you may be able to add panels to a solar edge system, a DC coupled system, without triggering the change from net metering 2 to net metering 3. The rules for this are fuzzy right now. PG&E said you could, and then they're kind of changing their mind. So stay tuned on this. You'll have to talk to your installer and who's doing your interconnection to find out exactly how you can expand that existing SolarEdge system without triggering a change to net metering 3. All right. So we talked about adding solar panels, adding inverters. That's kind of complicated with all these details that I went through. But let's talk about something that's really easy. That's adding a battery to your system. The change that happened with California utilities is basically they say you can add a storage battery, but you can't add more panels. So it's easy to add an AC coupled battery to just about every single solar system. AC coupled means that the battery has its own built-in inverter in addition to your existing solar system inverter. Actually, they don't talk, you're just mutually controlled. So basically you have two inverters. One inverter for your solar system, which you already have, and then when you get a battery, like a Franklin system or a Tesla system, it's got a built-in inverter in the battery, it just operates independently. And what you do, and this is kind of cool, the solar breaker that used to be in your main electric panel is now plugged into the battery system. So the battery system will actually monitor the performance of your solar instead of having it done independently. So now if you're adding more solar panels or doing anything else, you can kind of control that all through the gateway for the battery system. Much simpler. So we see this happen pretty often where people say, all right, I have an old solar system. I want to add 10 more panels. I'm going to use a SolarEdge system or an Enphase system. We just add that on and we put the two breakers inside the gateway for the battery system. And then the battery system monitors the battery, but it also monitors the production of each of the solar systems. It works out really, really well. Now, we talked about AC coupled systems, which is pretty easy to add on. If you have a SolarEdge system and you want to add a battery, they have a really good DC coupled system. And there's a few other manufacturers that are starting to come out with these DC coupled systems. They're kind of complicated internally, but from a customer's perspective and installer's perspective, pretty straightforward. So the SolarEdge inverter will handle the DC power from the rooftop array and the DC power from the battery. So basically DC coupled means you have one inverter, and that one inverter gets output from the solar system, typically at 400 volts DC, and it also gets output from the battery or input from the battery, depending on whether you're charging the battery or discharging the battery, also usually at around 400 volts. So very elegant. It's about 5% more efficient on a round-trip energy usage because you're not doing an extra conversion from DC to AC and back to DC when you're charging, and it works out great. And it's even more benefit if you have frequent blackouts because these systems have better changeover. All right. So we talked about a lot of constraints. I might have kind of gone into details a little bit too much. These are things that your experienced solar installer should really know. And you may have to kind of, the salesperson might not be that familiar with it, but whoever's doing the engineering with your solar firm, they should know. So my advice is if you want to expand your system, talk to your original installer because they're the ones that are carrying the warranty on your system. And, bringing another installer in who's going to be kind of taking over the warranty, that might be a little bit of an extra expense, but you want to get somebody that's experienced. So most importantly, talk to your original installer. And if your original installer is not responsive or no longer in business, and we're seeing, there's a lot of changeover in the solar industry, find another installer that has long-term local reputation. And the reason why long-term is important is because you need to find an installer that has experience installing these old systems so they know how to add on to those old systems. And a lot of companies that are new to the business, they don't even know about what was happening in the past. It's kind of like working on an old car. Almost kind of like working on an electric car versus a gas car. There's just so many more complexities with these older systems. Now, if you have a leased system or a PPA, this is called third-party ownership. So usually you finance the system and you're paying monthly. The leasing or the PPA company basically owns the system. And they're not going to allow you to change the existing older system without their permission. And it's usually kind of tricky to get that permission because if you're changing that older system, it's going to affect the warranty on their system. And they don't want anybody to touch it. So one way around this is if you have an older leased system or a finance system or a PPA system, you can add on a separate system as long as it doesn't affect the original system. Basically, that means put in a separate inverter, put in a bunch of microinverters, separate circuit breaker, and you're going to have basically two completely independent systems. All right, kind of summing things up, basic advice, just these are the most important points. Expanding an existing solar system is more complicated than the first-time installation. If your system's older than about 15 years, in our experience, we suggest replacing that old system. The new system's going to have twice the output, it's going to be safer, it's going to be more efficient, and it's going to have extending that warranty for another 15 to 25 years. Now, in California, you can't expand your system by more than about 1,000 watts. That's fewer than 3 panels. And that's just something you have to keep in mind and figure out, is there some way around that or some other way for you to generate that energy? All right. Once again, in California, and really everywhere, it's easy to add a battery for backup and time-shifting energy use. California's rules allow you to add a battery without affecting net metering. Most other states really don't care. So most important advice here, make sure you work with a solar and a battery contractor that has years of experience in expanding these systems, because the newer ones may not really know. So just check your references, find somebody that's around, find somebody that actually does a lot of good service work, and that's going to be the best solution for long-term success with your expanded solar system. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.